Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and we finally completed the SG kit, and now we've completed the larger model for the SG kit. This is the book that we're giving out for the kit. It's a 50-page book. I've already gone over the details in the previous video. So the original SG kit is demonstrated right here. This is for small 12-volt batteries, and it's called an Energizer. It's a mechanical oscillator, not really a motor. So today we're going to be focusing not on this kit, but on the larger model, the original 10 Coiler Monopole by John Bedini. So these really go together, and if you're going to want to do real serious research that we did 20 years ago, then this model right here, the 10 Coiler, is really the ultimate for when you're using mechanical oscillators to do this research. And we could talk about that later on. So let's get into the details of what we have here. So in the smaller one, we have a little bulb here that's lit up, representing some mechanical output if you want it. And we have a 2-battery system. I'm going to turn it off now, in which one battery is being charged and the other one is powering the motor. Now the other one is going to charge for free, and you can look at all my other videos to get into the details of all that, but I just wanted to mention the basics. So in this case, what we're doing today is going to show you, this is the first product that we made for this model. Now you can look on the web page and see the original SG picture, the original 10 Coiler. SG is schoolgirl, because the 10-year-old schoolgirl ended up in the year 2000 winning all these science fair awards in Coeur d'Alene school, and so this circuit was called the schoolgirl circuit. Now with this particular model here, I've made this before about almost 20 years ago. It has a special rotor inside here, and so this is advanced. But before we get into that, I'm going to mention just my setup here. So what we have here is, I've shown a video recently of these 2 batteries. There's one underneath here as well that I received recently because they were shot batteries. Now both of them had about 5 or 6 cells that would have had to been replaced, and the rest of them would be following soon after if I hadn't rescued them. So I picked these up, $200 a piece. Pretty good when you consider these will be about $5,000 to $6,000 a piece, brand new. And so far I have all the cells back to normal, and one cell in each of them is still bad, and I will be working on them separately later on. But what's interesting with this technology, with the battery charging that we do and the battery charging done with these motor oscillator systems, Energizers, is that we can see them increase in capacity and actual voltage. So what will happen is that a typical 12 volt battery, lead acid battery, will sit brand new at 12.65 volts after fully charged, coming from the factory. Put a conventional charger on it, and that's where it will sit after it settles. And with this charging, you can see the batteries sit immediately at about 12.8 volts. Can be higher than that too. So then, after about 3 months of using this daily, this technology, the batteries can sit at about 13.3 volts. And these are not sealed batteries, which will typically sit higher voltage. But these are open flooded lead acid. They have caps here, they've got water that you can pour in. That's what you want. You do not want to spend your money on sealed batteries because you can't put the water back in them. So you would have to use sealed batteries very lightly, at least in the charging side of things. When I was starting as a mechanic 36 years ago now, I remember being told and shown, and back then they showed you a sealed battery should only be charged at 2 amps. And now they don't tell you that because they want you to replace the batteries more quickly. If you do that, then you can keep them longer. And I still have batteries that are 15 years old that are still working, that are sealed batteries, because I charge them at that rate. Anyway, so I've got one cell missing here, and this one is not hooked up right now, but it's kind of a table right now for this. And so now I have 46.3 volts on this. It was down to 46 volts, and I ran this for a little bit just prior to starting this video. But what happens is, when I rejuvenate this and bring it back and increase the capacity, it then can be functioning like a 48 volt battery with 24 cells, but now it's only got 23. And in this case, I can move the cells around. So I put this one on the corner. So it may be able to come back, it may not, we'll see. The other ones came back. And in this one, you can't move it around. So I would have to short it right through both terminals in order to do this. So if I can gain in voltage in these batteries, then it can function the same way. Because I've gained higher voltage, and then that 2 volts that I've lost will be recovered. So I've been doing that. I actually rejuvenated these, finished doing that, at least these other cells, about 2 weeks ago, and I've been running my water heater here down many times, and that takes 4,500 watts. So initially, now this is just a piece of information that is useful that I talk about daily with everybody. If you have a bad battery like this where it's not working like it used to, what you want to do is load it down, like charge it up and load it down with a high load like that, 4,500 watts or more, or whatever. This is a bigger battery, so you could do it that high. And then you want to check each individual cell voltage while it's under load, not under rest. It's a big difference. Then you will see the relative voltages. And these ones were all over the place when I did that. In fact, I couldn't even run 150 watts before this would just go flat dead. And that's after conventionally charging it. So I did manage to check all those voltages, and then I marked which ones were the lowest. And several of them were going negative, even at, like, so the voltage read negative. So therefore, those cells would have been normally replaced, and the other ones really weren't doing anything either. But they were different. Now they're all exactly the same under load. So that's really good, except for the one which I've separated. And that's in both batteries here. So that's almost $10,000 that I gained here in useful batteries. And people are going to lithium, so it's the time to use this technology to grab up all those. We sell the battery chargers, of course, and we're more interested in doing that than rejuvenating them and selling the batteries. Anyway, so this will be 48 volts, which is 46 right now, charging, while this is going to be run at 24 volts. Now it says 25.1. So these are discharged a bit, and normally these will sit at, they haven't been charged in about 2 months, and they were used already at my last meeting. So therefore I haven't charged them up at all yet. So they're going to be running that. You'll see them drop a little bit, and then they'll be charging this battery bank. So this battery bank has to do several more charge cycles, and then I will start establishing its actual amp hour capacity. And so that's what's covered in this book about how we do load testing, proper control load testing. And we usually want to establish a baseline of 10 cycles, so we really know where that battery's at. And we go with the standing voltage, and we like to actually charge at the same rate that we're discharging it. And then we can really get a good understanding of where our batteries are at. We have 3 products that will do that as rejuvenators. We've got the 2-volt forklift charger that does the single cells, which is what we'll do on these 2 cells shortly here. And then we have a 12 and a 24 volt model that will discharge the battery, measure the amp hour, like on the 12 volt down to 10.5 volts under load, and that will stop measuring at that point. And then it will start from the high voltage going down to the low voltage. Then we'll charge it up, and then it does it again and again. It tells us the percentage gains and also the amp hour each cycle, each load cycle. So that's what we do either by the machine or by hand with resistance loads that are constant. So then we can determine really what we're doing, because otherwise you're flying blind. You can't just take a sulfated battery. It would be misleading test to take, and I've seen people do this. There was the energy bat guy went down to his lab, and he showed me he could charge batteries within literally a few minutes. And I let him speak, and he thought he had something really substantial, and he was going to show me. And so then he charged up these batteries, supposedly. The voltage went from low to high, and you know, I had to explain to him, well, you don't have any real capacity in those batteries. And he just didn't know that, right? But so the point is that you have to establish what your real amp hour capacity is, and then do your experiments to see what you get from that, what you put in, what you put out, what you get out. So here, I'm not going to try and do that. We could have done that. We've got a whole bunch of banks of batteries here, but I wanted to just highlight these for now and get into the details of how you run this motor and so forth. So I wanted to leave the voltmeters on because I want to show that we're not deceiving anybody, to show you the voltage. A deceiver would charge up, let's see, they would discharge this battery, the high load, start the video, then start running it, and then make it appear, so this was going to drop in voltage under load, and then it's going to bounce back even without charging. So if some deceiver does that, you can know when they start the video immediately, and then they show you, they start the motor or whatever they have, and then they will turn it. Now don't get any ideas and do some bad videos. I will find out and call you out on it. Anyway, so they will do that kind of trick where they will start the video and make it appear that it's charging really fast, especially with a sulfated battery, because then it fluctuates so rapidly in that context. So what I usually do, and I've been doing this for 20 years, showing you the voltmeter, talking for a while, showing you the voltages, and then starting it up and showing you all the details. But again, I'm not trying to prove anything in a video. I'm showing you how to prove it to yourself. That's only the claim I ever make as a scientist. You cannot prove free energy in a video. You cannot disprove free energy in a video. You can see my video about 4 or 5 years ago on that, where I was demonstrating free energy. But I was telling you, you can't prove it, because videos all could be faked. All pictures and all videos can be faked, and have always been able to be faked from the very beginning of photography and video. So you cannot believe anything through a video, absolutely. Do not fall for the tricks. And I'm not just talking about this subject. So anyway, let's get into it. What we have here is, in this case we only have one coil on this little one. On this one we have 10 coils, and can you guess which one's the master coil? So you can see all these ones are all exactly the same, and then this one is slightly bigger because this has an extra wire. These have 4 identical wires, and we've twisted them. We call it Litz wire or twisted wire, and like typically around 1 turn per inch. This one's a little bit tighter, depending on how many wires you have. This one has 5 coils because one of them is a trigger coil. So this one does not have any positive energy input to turn the transistors on. There's no Hall switch or opto switch or reed switch. In that case, reed switch is not magnetically powered. But this one is also magnetically powered. So it's a sense coil, and you'll notice that it's slightly off center. Just a little bit, and we still have to adjust it and tune it. I'll leave that for the customer to do. So we have a slot on the back, and I'll show you that later, where this could be adjusted. Now all these coils, you can see they have, you might be able to see it in the video, I'm not sure. So we can pull them all out by slightly loosening the bolt in the back, and we can position them. So if you wanted to do experiments on this, then you would just focus on the master coil. That way, if you do something wrong or damage, you're not blowing out all these 40 there's 40 transistors here, which you'll see on the back. And then you'd only have 4 to deal with on the master coil. So master slave coils. And so the difference between this and what we've usually done over the years is, which has been just a minimalist design, is that we have higher inductance in this motor here, in these coils. So if we have 8 wires, then there's only so many turns that we can, taking up more volume, and so therefore there's less length of wire. So these are around 200 feet. So they're exactly the same, down to the inch. There might, on the back, when we connected all the wires together, we tried to bring them to the same point. And there's only so much you can do exactly like that. But we wanted to get this really tight in tolerances and everything. Now it will take a little bit of time to place these exactly, which is, I had to do this by hand. I mean, we had these these parts, but everything else was very precise, and I had to do it with wood because the plastic was really heavy for shipping overseas. It was 3 times as heavy. And now this has plastic here. This is literally a wagon wheel. This is exactly like Bedini made it, and we have some plastic on the outside. On Bedini's, he covered these magnets, but this worked out to be this way, where I put 2 plastic pieces on either side. This one's a bit wobbly, but it makes no difference. You'll see it, but it'll be the same hum, pretty much the same RPM. I have the same trigger resistance on all the bases of the bulb, exactly the way Bedini did it. Now, I don't think he really ever showed a close-up. I have shown it. You can see my video on the page where I show you the close-up. I held back those pictures and video until Bedini died because he asked me not to show the video, show that. So then I agreed to that, and of course when he died, then I posted for everybody to see the details. And so I of course had that knowledge all those years, and then worked with these systems. So then so there's a very specific resistor value that is on each trigger resistor, and then there's a bulb that you'll see running that does the impedance matching as the impedance changes in the battery as it charges, and as this one discharges, it changes the rate of charge and the impedance in the circuit. So you can get this really balanced all out if you deal with all the weight of the wire and everything. And so what John Bedini did, is he actually calculated the wire lengths and all the impedances within reason to make an ideal system. So ultimately, we don't the first stages that we were doing 20 years ago was to focus on charging really big batteries. Now he had 2,000 amp hour batteries, so I have altogether here in all these batteries here at the shop 2,000 amp hours worth of batteries that we could charge as the output like he did. Now there was 2 different banks that they had there. One was smaller than the other, but the bigger one was 2,000 amp hour. And I had that in my shop, those batteries, for 3 years, and you can see the old videos where I was showing that in my shop back in Coeur d'Alene. I was actually Hayden, Idaho. So what we did back then, starting about I think 21 years ago, really approximately, is this system will have a different type of energy output than the input going into it. So what we call regular DC current, or even AC, we call that positive energy. It's energy that you see along the conductors and in the battery, creating heat and there's losses supposedly in heat, which I actually teach differently than that too. But the point is, that's what we call positive dissipative energy, and that is what you deal with in entropy system, where you have the laws of entropy and so forth, where in the thermodynamics laws, where energy scatters, and so heat and you have losses in the system. On the other hand, what we're doing on the charging output, and that's this wire going to this battery, and then this black wire going to this terminal here. So we got this terminal and this terminal. And then these big wires will go to the generator to discharge it, or the inverter. So then we have this output that's opposite, so we call that negative energy. I don't like the idea of using the word radiant energy. Tesla used that in a different context. John was using that word radiant energy, but that is misleading in the sense of the way people understand that word, which is radiation. So like I have heat lamp going on right now, bulbs in which you can feel the heat, at a distance radiating. And that is really not what we're looking to use that terminology. I don't really do that. So negative is a good word. Now, negative energy has different meanings conventionally, sure, but it also is being used in the same way that we are using it. So when you have this across a coil, when you are pulsing this coil, there is something that happens after you turn off the power to it and before you turn it on. So in other words, immediately when you turn it on, at that instant, something else takes place that is faster than the current flow. And then once you turn it off, the same effect happens, but more amplified because it's a higher voltage. That's the magnetism is built up in the coil, and then it collapses. And so that's what everybody focuses on. I've taught about this for years. That the turning on is the same as the turning off, but nobody talks about the turning on point, but a few of us. So anyway, there's this other type of energy that has opposite characteristics. So it's a cold energy, it's a currentless energy, and so there's about 7 characteristics. But the other one is the convergent energy. So the energy converges in from the environment somehow, whatever your theory is, doesn't matter to me. I measure the phenomena. I show how to engineer it and utilize it. What it isn't always understood. But we have these characteristics of the effects. There's a difference between what it is and the effect. So that's very important scientifically, that we don't confuse the cause, the thing in itself, and the effect as if they're all the same thing. Those are 3 different things. So the effects are that we see a battery charging when it shouldn't be charging. We see the conductor energized going to the battery. We add bigger batteries. So let's go back to the beginning. When you had this little inductor and you have a pulse motor, and if you don't have any controls on it, it will eat up your switch, right? When you have a loaded circuit, connect that to the battery while it's loaded, boom, you'll see a spark. And you can even see a spark at times when you pull it off. So that's considered negative energy in various contexts. So then what happens is Initially, they will put what's called a snubber system. You have your flyback diode. You have all these different terms used to describe this control. Like when the Edison power lines were miles long, they could only be a couple of miles because of losses. So they would power local areas, like in a city, with DC at first. And then when they connected the power source, the dynamo, to the power lines, you have sparks flying off there. And then down the line, before the current could even reach that point, you'd have the sparks flying off too, instantly. And then when the current caught up, it would stop. So that was what Tesla discovered and engineered at that point. And that's what we've been focusing on for 20 years. So what happened then is, like in a circuit right now, you'll see a little diode going the opposite direction back to the input side of the coil, and then, which is the outer wire here, and all these. So then, like the outside wire that, anyway, so what happens is you have a diode going backwards. In this case, we have it going to the charging battery and not to the input battery. Then what we do is, or what they did, was have a way to, there's some excess energy here, and it's a problem, it's a nuisance. So they have to dissipate this. So they put it through a capacitor. The capacitor kind of collects it, and then there's a resistor that dissipates it. Boom, you're done. Now sometimes you can use that to also show timing and whatever. But since the capacitor is so small and they can't really measure any current there, no one's ever really thought, well, this is anything significant. So what happens is we take a bigger capacitor and find that it charges more than a smaller capacitor, and then we add a battery which is 1,000 times more capacity than a little capacitor. So say, well, a small battery like this, and whoa, we're charging this battery. And then we go to a bigger battery bank, and whoa, we're charging that battery, but not in a linear like estimation. It's not like it's taking like if this is a 4 amp hour battery, this is a 210 amp hour battery. Is charging. This one's charging exponentially faster than it should if it was just current, right? So then we go to a bigger battery, and yet we still get more charging. So when I had those batteries, and I showed a video of that years ago, where we were charging the battery like with a little motor like this, but we were running 2 amps input, and then I took the 12 amp hour 12 volt batteries or battery off the charging side and ran it into the 2000 amp hour battery at 48 volts like this, and now I was getting about 200 times more output than my input going into the motor, and also more than I was getting from the other battery, just simply by changing the size. The motor did not change speed or notice any difference, and so that's phenomenal. So that's where we say, you look at it like Don Smith's system too, where we have the heavy side. He talks about his one patent, where he puts the plasma tube in the middle, and then he's got these capacitor plates perpendicular, and he's collecting all this energy, and there's no change in the plasma column. It's not being affected. It doesn't know it's there. So this is what Bearden talked about, the heavy side flow on the sides around the area. the whole area is being electrified, and we're only taking advantage of a very small pointing flow, supposedly, in regular circuitry. So you can do a high voltage line too, where you have multiple. So we did that too. So anyway, with this one, if you look at this as sails on the wind, in other words, we have more surface area being affected by the wind collecting, and that wind is like endless, so we can make that as big as we want. It's different with the wind because the wind will only go in one spot, and if you have another one behind it, it won't gather any more wind. So that will be blocked at that point. I mean, to some degree, because it can go around it and then continue on. But the point is, these batteries are like different cells in the wind. So here's a cell, here's a plate, and it's not a current going through there, it's something else. And it doesn't really matter. I call it negative energy, whatever. So the energy is converging into all the collectors. So we want big bus bars, even bigger than this, on the charging side. Input side, not so important. But I will say this before I forget, if you can see this in the video. Yep. So we've always put a big capacitor on the input of these systems here. And most people haven't done that. And this is what you'd have on an amplifier as well, and an inverter. So now this one has these wires here that are not appropriate. So you'd have this is right at the point where all the connectors are tied together. So we'll look at that on the back afterwards. But this is where we have it as a filter of sorts. So if you have these being negatively charged, is what we're talking about in this system. Like this system is not meant to rotate the batteries, but we can start approaching rotating the batteries by putting a big capacitor right on the front end. That acts as a filter, and whatever is happening in these batteries is somewhat of a mystery, but it is not, once you've run this fully like 10 times with this type of system, this battery bank then becomes, if it's rejuvenated and clean, then it will be negatively charged, and it will have different phenomena. It will act similar to a capacitor. It will continue to charge after you turn this off. Like the more you do it, at a certain point, it will continue to charge for another 24 hours, noticeably. Not like conventional charging that stops within minutes. And then, so you can see that, and there's a whole thing about rest periods. So I'd like to do this, and I've mentioned this many times, but nobody's ever taken me up on this. If you had 3 battery banks that you're rotating out, you have to do that carefully, that making sure that you're never disconnecting the output ever while it's running. Because then you'll have that same problem everybody's trying to avoid in modern electronics. So, but if you were to, like, say, parallel one for a second and then remove the one and leave the other one on, and you had 3 battery banks rotating around, you get considerably more output by doing that. Because once the batteries have been conditioned, then, so there's rejuvenation, there's capacity increase, and then there's conditioning, which is part of the capacity increase. But in this case, with the negative energy, this thing then charges more. The bad side is after it stops in that charge mode, it will start discharging. So it rapidly still charges, but then it will kind of rapidly discharge. And so you'll see, if you walk away from your experimentation for a week, you're going to see the batteries gone down. So this is meant to be used right after you charge it. And so that's the downfall of this. Now this is the basic level of the technology that I'm talking about. We can get into a single battery bank or no battery bank too with this. Capacitors are a lot more expensive, so it's actually not worth it to try to do a capacitor bank over a battery bank. But that's another story, and we have another motor coming up that we'll get into along those lines. So this can be done that way too. But what I'm saying right now is the basics. So when this battery, so in order to rotate the batteries now, we would have to put a filter in on the front end, or what we do, if we want to keep the batteries negatively charged and work with negative batteries, then we operate with doing something on the front end of the motor. That means the input side from these batteries, not on the battery here, but on the connectors connecting into the system on the back. So at that point, we put this filter in there, and we can do a little bit more filtering with inductance and resistance to not have any adverse effects on this motor that it requires more of a positive energy. So we can change the negative to a positive energy, and it's all kind of relative terms, and I don't expect you to understand it, but it's actually an interesting observation to watch these things. And I'm remembering I think Felix said to the Apostle Paul, "Your great learning has made you mad," and I feel like the same situation. I can't really quantify it for you in your experience. You have to experience it yourself. You need to know Christ yourself. In this case, you need to know this by experience. And the other thing that we have always talked about is if you convert a battery to negatively charged and you try to put a positive charged battery on it, charger on it, it won't do anything until you reverse that, whatever happens internally. Then it will come back and operate just like it did before, and it'll be more of a storage battery in that case. And so, like, if you put a month into it of charging, it's going to take a month to convert it back, and that's where you know you've really got this negative charge. So it's actually quite interesting to observe that. People think that they've damaged their batteries, but they haven't, and they're just been changed. So that's that. So now we're going to get into something else here. What's unique about this motor, we've never sold this like this before, any of our products. We've done them privately. We've talked about it. We taught on it. But these are what John called the scalar pole arrangement, where the two north poles of a magnet are pressed together and glued together, and they create what he called a superpole. And you call them scalar or superpole or whatever. I don't care for the word scalar necessarily, but what you have is a very narrow beam going out, and then you have the rest, all this from here to here, from the center to the center, is all a big south pole that comes out here. And you can see that picture in here, right here. So this is one of John Bedini's lab notes right there. And you can see it's not really good quality picture, so even if I posted it in there, it wouldn't. But in there he talks about this too, and elsewhere in some of the videos. But anyway, there's a couple of advantages of this. One, it's a very sharp gradient. So what you have is, what we want is a very sharp turn on and turn off. The sharper that is, the more the energy is multiplied. And so if we look at an oscilloscope, we'll see a spike is what we call, which is not what's happening. It's merely showing the effect of the probes of the oscilloscope. And so make sure you understand the difference between the effect and what's actually happening. Trying to meter it is totally different than what is happening. So now, on an oscilloscope, looking at that, you'll notice that the spike goes so high. If you have a really sulfated battery and barely a load on it, the spike will be much higher. If you have a faster oscilloscope, you'll see it goes higher. So I went from like a 30 megahertz scope to 100 to 200 to 500 to a gigahertz scope, and every time I went up I would see a higher spike. So in my view, the spike is infinite or whatever. It's just how fast in a short period of time you can measure that is showing on that oscilloscope. So anyway, but nevertheless, even like, so typically you call the spike what a 100 megahertz scope shows on a good battery being charged. And so you can see at least a 300 volt spike on a 12 volt input. Here we're doing 24. But on 12 volt you can see, so typically we say you can charge 300 volts of batteries on that. It's not the best to go too high, but depending on the condition of your batteries too. But here we get back into this, what some people call pinched field too, or so what happens is this is a very sharp gradient. Boom, and it's just hitting that coil like you hit a bell. Ding. Oh, that oscillated a little bit. So then that's creating the effect that we want to harness. It's triggering the environment to rush in. Like we've created this voltage, we've created this potential difference, and it's sudden, and so there's this immediate wanting to rush in and balance things out, right? So that's what's happening in the battery, and it results in battery charging, and also other phenomena, other types of loading with light bulbs and so forth. And of course, if we have the bigger conductors, they are then energized for that split second before any current can flow. So it's not a current phenomena. So in this case, the advantage over this motor, which has the North Pole, like say this was the magnet, and that's the North Pole on the outside. Say that hole represents the North Pole, and it's going around. The on time of that is a lot longer than this short narrow beam in which we have here. So this has got no mechanical power in it, therefore, because in order to make a motor, you have to have longer on time on the switching on the coil. So this is a different way of doing the Newman effect, which I'll call it the effect, and I'll give Newman credit where some people didn't want to. Newman did what we're doing here with these wires by making a higher inductance. He did the extreme of that, and obviously it's not practical to use all those miles and miles of wire, but what that did is allowed for the mass of the wire and the higher inductance together gives you a higher, a stronger magnetic field for lesser input energy. And so when we went up to this higher inductance, less strands of wire, then we got a lot more charging output, and you can have a lot more mechanical power for the input of current energy. So then, but instead of going with, so one of the points along those lines is if you create a circuit that only runs for 1 nanosecond or even less than that period of time, and you pulse a battery with the right off time between those nanosecond pulses, you'll not discharge your battery. But you can create what Jerry Vasilevsky called the Tesla effect, in which you can have on the end of the circuit, like Tesla was doing with like his one, what was it, 96 patent, somewhere around there, 1896 or something. He showed the 2 different models where you had chokes, large chokes on either side of where the dynamo connects in, and boom, very short on time. And then the capacitors behind the chokes would charge up, and then very low inductance, primary of a transformer would be that circuit there. And you have the spark gap that was quenched just in the same way this is being done here. So this is a lot easier to do. It took Tesla 10 years, as he said, the 1890s years, 10 years there, to perfect his whole system. And so this accomplishes that with this pinch field, or very short on time, and it's just a slap, very short. So we can get this tuned to take very little input energy. We're only going to do, right now I have set it up for about 4 amps at 24 volts. And the way we were running it the other day, when we just finished putting it together yesterday, we were going up to 10 amps. But I have the bulb in the circuit that you'll see. So we can adjust all that by putting various resistors, and I'll talk about that when we turn this around. So then so the other point is, the other advantage of having the magnets this orientation, and I did that on my big boat, by the way, and I haven't really talked about that. So we were using what we call the window motor, which is really a Newman motor, but better than a regular Newman motor. A lot less wire, but still a lot of wire. And I oriented the rotor in this way as well. And the advantage, second advantage, is in this case the off time. So the off time, okay, so if these were oriented the regular way, you'd have a longer on time, and then between the magnetic, the North Pole would be much wider, and so the off time would be a lot less. Here, the off time is from here to here. So ideally, like we have on this one, we have only three magnets, like one here, one here, one here type of thing. And so there's a long off time. It's more ideal because the battery continues to charge while the circuit is off. Remember, this isn't really meant, these two aren't really meant to be motors. They are negative energy oscillators. And there's a difference between a positive energy oscillator and negative energy oscillator. And we've talked about the differences in the effects. So now, in this case, the batteries are going to charge, like on all pulse motors. If you have this kind of phenomena, you can have continuous charging from here to here. And so we've done motors where I have 1 second rest times, like the pendulum. So the pendulum had the highest rate because there's the longest off time. So, and I've done pendulums like this too. So this is giving you all the bare bones. And I guess I could make this a private video, but whatever. So then, what else? Okay, so let's get into, so this is the basics, right? The basics are that we are charging, we're after multiplying the energy further by creating a bigger battery bank, more sails in the wind. But now we can do other things. And if you want to read all the books by Jerry Vassilatos, you will find the introduction of the biggest one to be the most important of all that has ever been published on the subject. Well, there is stuff that is in patents, which those have the declassified patents. That's what that book is about, which you don't want to read those. You only want to read the introduction. The rest of it, as he calls in the introduction, are evil patents. And I don't want to get into that. So anyway, the point is, of all the published stuff, which he gets into what Tesla was doing more specifically than in the Secrets of Cold War Technology book, that's good, but it goes beyond that in this other book. So 15, I think, pages of full-size pages of great detail. So there's all sorts of other things we can do with these machines, different types of energy systems. So, but what we're after here for creating extra energy, so this system right here could power the entire United States. Now, it would be kind of ridiculous to try and do that. Like, we have to do extra processes, which we've shown. There's 2 videos that I have on my channel. You can go back and see that we filmed over about 10 years ago. One in Chicago and the other one in Hollywood, Florida, at the Renaissance Hotel. But we also did this in Hamburg 5 different times, and I have other videos showing this, where we multiplied the energy out again and again, and the input battery stayed at the same volts as, and then the charging battery didn't move either. And then we just turn on loads at will, and everything still balanced out. But we had to have a proper circuit. In that case, we usually do a resonance circuit. It's not entirely dependent upon resonance. It's more the impedance phenomena that we're dealing with. And that relates to what my friend Carl called the hairpin circuit, which is not really a proper name for it. But when you had those bulbs where you had this really big inductor, it's not really meant to be a loop, it's just convenient to do it that way. It's really, as I show in this book, a 1-wire circuit where you're connecting at 2 points here. But there's 5 different ways of doing this besides just connecting here and running your circuit here. So you can do it with or without resonance. Obviously, resonance makes a difference, and it's negative energy that makes a difference than these positive energy flows. So that was important teaching and demonstrations. Bedini never demonstrated that. He only showed you the basics that I've been showing you in this 3rd stage process, where you have added circuits along this wire. So you would put various inductors in series with, like in this wire, like so you cut the wire, you put an inductor in between, and then you have like a bridge rectifier and go out to another battery. That's the basic level of it, and I started showing that in 2005, and then we did the video. I did it on the groups, which as far as showing you all those emails, I still have to find a place to host all the thousands of emails that I wanted to do with this kit. So I just don't have the time right now to upload everything and find a place, because there's no free hosting anymore. So like the Yahoo groups had. So we'll get to that when we can. But this video is really completing this kit and this kit right now. And what we're going to do is start up where people do replications. People are already starting to do it. Like tomorrow I send out the rest of the kits for those who are waiting. It's taken me a while to get all these parts and everything. But I have them as of tomorrow. Thanks to Michael Crosswhite, who's giving the circuit boards for this. He's sending them, they're coming tomorrow. So, but what we want to do is have people replicate like they did back in the old years and post their information, do some videos. Then I put it all on one YouTube channel, a different one than this one. And then every person who does that, they put their data on the video, they put their pictures on the video, because this is the only place for free hosting is on YouTube now. So I figured we'll just do it that way. Instead of hosting files, we'll just have it all in the video. You pause the video, read their information, and then we have this as the science around the whole world, like we did years ago before Bedini deleted it, because he was control. Remember that? And that science was lost. So now what we'll do is show that again, and people can start replicating. They submit that in, and then we post all that. Then they can be talking to each other privately. That way there's no chit-chat, nonsense, distraction. If people want to get involved, they can post the results and then talk to each other. That's what we did before on the private groups. It worked well. On the other groups, there was always all this drama, and we don't want that. I don't have time for it, so we're going to make something rather than nothing. But right now, I had to finish up the content, and that's done. So anyway, on the advanced level now, we're not doing a regular circuit that's in series here. It is in series, but it's more on the Tesla side, and that's what I get into this book. Now it's still, and I get at least once a week somebody writing me on my resonance kit book, and now in this book. I'm so glad you made us experiment and learn it ourselves rather than just be told what to do. Now I give you the parameters, but now it exercises your mind. I don't care if you have free energy, really, because you don't really need it unless you're in these really poor countries. I do care if you're helped, but America, it's not really. Nobody's really desperate. Everybody can find a job and work and pay their bills. But what I do care about is people thinking for themselves. And we've always made these kits to learn from. And really starting with the Resonance Kit 1 and 2, I really made it so that you really have to think and experiment to see. And then I left it like, where's the mystery? And so now we have about 5 different points that are mystery points that people have to guess which one I was referring to. I wasn't referring to one. There was many. And I don't know if everybody's found out everything that I intended to find. But the point is, it's not too hard to, obviously, without even having to experiment, I do give you a lot of stuff. So on this, there is just as much to do. Well, not quite as much as on the Resonance Kit. But on this, there is still, they overlap each other. So you could get this running at a certain RPM, and like I show in the videos, 10 years ago, and we demonstrated this in the black box. So that black box had multiple switches, and on the one side we were doing the basic thing that Bedini and I were showing in video 7, Tesla impedance phenomena, or circuits, or whatever it was called. And that's the one basic level that Bedini was showing. And then on the other side, the right side of the box, we were doing the real process. And that was the one that could be multiplied as many times as you want. So what happens is that could be a prime mover. This could be a prime mover. And this is what I talk about in this book, where I learned when I went to Tom Bearden's house first time, and like exactly 20 and a half years ago, I went to his house and he told me various keywords. Series impedances was the final word, and then I realized it was in the context of negative energy. And so then I went beyond what Bedini shows in that video to do a multiplier process. I was teaching on that, and then all those groups were deleted. All that information was deleted. So I brought it back, shown it. It's the end of the matter. There really isn't anything more that you need to know after that. So the point is, this system, like ideally you would have one system, say it was a 5 kilowatt system, and then you just literally had a line going all around and returning back. I mean, that would be kind of ridiculous. And we talked about with Bearden, you could make one for every community and power it all, like all your neighbors. You can't really do that legally in a lot of states, go from one person's house to another one, but whatever. So consult your local code and do not go and violate anything, because I am not responsible for that. Anyway, so what I'm saying is you have a prime mover here. So this is one of the ways to do it. And then you could go, like say you needed like not just 5,000 watts and you had a system, but 10,000. So you go through one stage, and then you go through another stage, and then you go off to wherever else it's going to go to do more stages. And that is literally what can be done. And we have done it. And people are doing it. So, but don't trust me on it. I've said enough here that you can do this stuff yourself. You don't have to buy my stuff. I'm not a salesman here. I'm not trying to. I'm making these available. I actually, it took me more money and time to make this than what the guy paid for it. So I had to bump the price up now since he paid for it. I suppose we could get it down a little bit easier, but you'll see on the back side there's still quite a bit. Like, we had to make these coils very precise. Like, this wasn't just a hodgepodge of throwing wire together. It was precisely measured on our coil winder, and even our coil winder wasn't good enough to do this. So we had to take a lot of time to just make each individual coil. And then it's still going to take some time to align them all up exactly where they're right on the exact spots. And then this one, the primary, is slightly offset because it's got the trigger coil, and so it's a delay depending on the voltage you're running it at too. So this is something you got to spend a little time on, and I'm saying that for the guys buying it and for those who will buy it in the future. So that's that. I will start it up now. Now you can see the voltages. And I'm not really trying to do anything at this point because we should start off with a fully charged battery here, which we don't. And we should start off, well, this one is really discharged right now because I've run the water heater 5 times. Fully cold water to hot water 5 times. And this has got 1 cell missing, remember. So let's look at this now. I think we've covered everything. And then I will bring the camera back here after a minute. Now this one is not self-starting, of course, and it is there is no shaft here on the front, which I may change that for the next one. So we'll see. So at the back here, I have a trigger coil, which is normally we have a switch. The switch then is turned on. But in this case, what we're going to do is just connect the wire. And sometimes you have to hear a thump. Usually, okay, if I have the trigger coil hooked up already, and then I turn on the input positive, like maybe if I do this, it's quite, sometimes it's pretty pronounced. So I'm going to connect up the positive. Huh. I don't hear anything. So hopefully all the wires are connected here. Let me take another look. If all the wires are sure they're... So what I'm going to do is start it with this jumper wire that will be shorting out the bulb to get it started. Well, actually, let's see if we can do that. Again, I haven't tuned this yet. I'm going to leave it for the customer to do that. So now what we're going to do is turn it in a certain direction to get it going. So this is going by itself now, yeah. So you can see it is starting to charge the battery. Now, these batteries are, they said 800 amp hour battery, but I think it's more like 600. And I'll know once I do all the loading on it. So what I'm going to do is bring the camera over there. And show you on the back side. I just have to take it off here. Alright, I'm going to cover it for a second here. So what we're going to do is look at the circuit boards. But first of all, let's go back here. View. So what we have here is this trigger wire that's in parallel with the motor coils. So we've got the two wires, well actually, so this is the master. Hold on, let me get this lighting here better. So we've got the master coil behind here. So this is the master circuit board. And you'll notice all these flickering LED, or not LEDs, neon bulbs. So this is typical. This is exactly the way John's was running. The way I made this 20 years ago, approximately. And so we have the bulb, which will go right here. This is where it connects. So this is the trigger bus bar. You can see these wires going out. And then this one upside down on the inverter. And then of course I was running the circuit into the board there. Don't try this at home, people. So right now, these wires right here are going over to this, which should be thicker and shorter. It should be like right here. Like literally, you would connect these two terminals to the top terminals right there. You have no wire. That's what John Bedini showed on his 6-coiler. So what we have here is the trigger wire going to the pot. Right now the pot is at no resistance whatsoever. If I change it, you'll see it slow down. And then it goes through the ball back to this trigger wire here. So that's it. So now we're going to show the amperage. So now we have, this is the input wire right here, positive input. We're showing 4.4 amps. Well, it's backwards. Still 4.4. You can look at the negative terminal. And of course, this is not going to be showing anything. It might actually show some AC, but probably not. Oh yeah, see? It's going back and forth. So that's what it should be doing. So anyway, so we wouldn't want to have all that line there. We would want it right there. Now, so this was my only opportunity right here to do. I just had to solder this into a proper tube. And you can make that tube bigger, but it's kind of a lot of work. Like we drilled holes in and then soldered it. So this is exactly it. Now Bedini had no circuit boards on his, and he ended up putting heat sinks on. But remember, we're only running this at, right now it's even less, but a 1/4 amp per MOSFET per transistor. And now we do have one advantage over what he was doing is faster diodes here, but it's not going to make much of a difference. So don't get hung up on this side of the circuit, as in, like when John had these bus bars all around here, that didn't do anything. Like typically what we want is everything exactly connected to the same place. These were actually the same welding rods that are in those right here. Right? Oh, and then before I forget, if you want these not to flicker, then you could get some higher voltage neon bulbs. And so he didn't want to go above 24 volts. If you're going to go higher voltage, then you're going to need to put what's called a branch resistor. So you see this white wire here, that's connecting to the bus bar of all the resistors. And so typically we would usually have a branch resistor coming off, balancing it out even more. So that's what the customer can do. They can put it between here and the wire. And then we typically have this bulb here. If I short it out, it'll show you the difference. And you can see when we're doing all this stuff, it depends on several factors, like the voltage you're running it at. Okay, so I'm going to do this, and now I'm going to short this out and look at listen to the speed. So charging rate, let's see this. Let's see what happens there. Okay, so 45.5. Now I'm going to do it again. I can see that it's actually going to be charging a lot faster too. So this brings me to a point with Bedini. You know, he says it's the fastest rate of, or sorry, the fastest speed of the motor to the lowest input energy, but that's not true. That's only a relative truth, or somewhat true. There's the other factor, the main factor is how fast you're charging your battery. So those are three different things, and people can't think more than two different thoughts, two different variables at a time. So it depends on, so really it's not supposed to be about the torque at all, but that is a factor. I mean, this will put out a little bit of torque. Let me try and see it with my hand here. So yeah, I could put a decent fan on that, but the shaft isn't moving. It's the wheel that's moving on the bearings on this particular one, because this is what this one's about. Like I said, we might change that. So that's all the details of how this works. These screws here, like you can see the slot right here, that I could move this, the timing. So really, this would be top dead center where the top of this hole is. And it's moved down just slightly from there. Of course, we don't really want this touching that. But that, so if you wanted to, you can loosen each coil. You can unscrew it or loosen it and pull the whole coil out, and then disengage all the coils but one and do your experiments on this one. But actually, it won't even drive it. Running that one by itself, well, I guess if these coils are removed, it should. But when they're left in position like this, it won't. So anyway, this is at only 4.5 amps, and it's charging the batteries. And so we could put a resistance, a fixed resistance in there, but the bulb gives you this impedance difference. So that is representing, definitely quite a bit of amperage to light the bulb up that bright. It's hard for you to see. It's not like the fullest brightness, but it's close to it. So it is about 12 watts, 1 amp of worth of light there that it would normally take. So then I'm going to turn this off. Oops. So let's look at these batteries before these voltmeters. So you can see there is a little bit of wobble on this one, but it's not really. We've got the Bishop's oil in there too, so that it will this one's going to turn off, so I'll turn it back on. So of course that's come down, and then this one. So you can see that has substantially charged. So you can see what I'm talking about here. So we connected up to this terminal, and these are the wires showing you. Again, I'm not really trying to prove something here, but you can see all these batteries connecting around. And see, these little things right here were indicating which batteries, which cells were down. I forgot to remove that. So this cell right here is the one that's pretty bad. And all these ones on here, these ones were all bad. And so I first did 36 volts, and then I did 48. So then what we do is hook this wire up here, and this one right here, to run the water heater and discharge it. So now I can turn it off by just disconnecting it. But you don't really want to do what I just did. You can see the spark there. You want to turn off what John called the sense switch, or switch number 1. So you'll see that now it's going to come down here, this charging, but it's going to still hold the charge. This one will come back here, like it'll go back up to that. Like basically we haven't touched these batteries, or at least these batteries here. So then, so you can still see in here. It's hard because the coils kind of push out, and like this one has got way too big of a gap right here. It's kind of hard to see, to get in there exactly. So they still have to be moved carefully. Like we want like a 1 millimeter gap. So that's where, I mean, we have not exactly perfect magnet placement there. There's one that sticks out slightly more than others on that one. There's a lot of work to do this. I had to hand file a lot of this. Anyway, so let's look at this battery, bounce back a little bit. And then this one come down a little bit, but it's still relatively going to hold its charge. And again, if I was to run this where like I had it almost fully charged, then this thing would continue to go. But this is the first time this battery has ever, so it's still a positively charged battery, and will be, like I won't even have the time to make, like this one's going to ship out tomorrow, so I will not have the time to convert this battery over. So yeah, the going back to this whole advanced thing, let me try and turn this out. And then we can just put this one over here, so then you can just keep these together. Oops. So the idea here is that we have the one battery bank here at not fully charged. And then we have this battery bank not fully charged either. And then they just stay. Like what we had, you can see in the video, we had like 12.59 running for an hour on the little small batteries that we had conditioned. What I did is I took them down, like I would charge them up with this, back and forth 10 times. So we would discharge them down to 1 volt. We'd discharge them with a bulb, because they were the small batteries, and bring them all the way down to 1 volt, or when the bulb was turned off. And then I would immediately charge them back up again, and then fully charge them, and then bring them right back down. And it would be a kind of a rapid way of converting the batteries to negative. And then when we would run it, we wouldn't have them fully charged. We'd have them like, well, Renaissance fully charged is 12.6 volts. Sorry, Renaissance charged batteries that are flooded batteries like this are 13.3 volts sitting, resting. So we would say started at 12.6, which conventionally would be fully charged, but Renaissance charges much higher than that. So now they would just hold their place. And that's what Gabriel Kron called. So this is Kron 2. Bedini made his showing of this motor being built called Kron on his Kron pages on his website. You can still see that website, not run by him, of course, but somebody else copied all the files and reposted them. And so we'll call this Kron 2 maybe. So that's Gabriel Kron, whatever how you say his name. And he was, one of the foremost electrical engineers in American history, who basically said there's three kind of alternatives. What he discovered, his lifelong search for this free energy, which he realized in what I'm talking about here today, which we're the only ones who have demonstrated it publicly, and it's probably the only video you'll ever see showing that. And yet nobody cares about those videos. It's kind of interesting. Even amongst you listeners, most of you don't really even bother to look for those videos. It doesn't really matter anymore. People don't really care about this stuff. So, but what Kron said was, so you have scenario 1, you have a motor or a generator system putting out down a transmission line, like a typical grid system. Well, he's talking about networks, and then that system draws energy from the generator. That's typical, what you expect. You're going to have to put in energy to drive the generator and produce the power. Then the other scenario 2 would be that excess energy was coming back into the generator. In other words, there was more energy coming in from the system, coming backwards into it, than what it was was drawing. So it's not drawing anything. But that's a problem. And that's what I was saying to a customer the other day, was we ultimately don't want, when we're doing the battery rotation system with the other systems, we don't want excess energy produced in the batteries, and then that has to have something to charge. So you can't, you're going to have to then, you'd rather take a little bit from the generator coils or off the output and then regulate keeping it topped up, or not even completely topped up, so that you can rotate those batteries around. So that's scenario 2. And then third is that the batteries just stay the same, like I said, in the ideal. And that's what he achieved, and that's what we've achieved. I'm not sure if Bedini ever did that, ever came to that point himself. He certainly didn't talk about it with me. He only showed what he showed in that video, which is what I had already done prior to that in the groups. So the thing is, that's what Kron said. Theoretically, you could remove the input. But the problem with removing the input is that it's still part of the system. So basically, you'll find out in the kit book that what I call this, what is it that he was talking about? And Dollard kind of hints at it with the synchronous condenser, which is basically a Tesla idea. And that's another whole story. So I think that's it. We can see that the battery is going to come right back to where I started, because that's what happened just before I did this video. But you'll see, this was starting at 46.3, but it had been 46.1, and I had only run it very shortly, like 10 minutes or something. So this will come down a little bit, but it will still continue to charge. But as it becomes more negative, it will do it more profoundly. Now again, this battery is now probably around 500 amp hour, 600 perhaps. My quick estimation, based upon what it's done in real work with the running the loads that I was running. And remember, this is not a 48 volt bank, it is still only a 46 volt bank. So, I mean, that doesn't really relate to what we're talking about, but so yeah, it does charge the batteries, but what I'm saying is these are 210 amp hour batteries, Costco batteries, interstate, and then these are no doubt, you know, approximately around 600 amp hours right now, and they're 48 volts rather than 24 volts. So, I mean, even in this run, I mean, it's really premature to say this, but from my experience that I've been doing this for 20 years, I can tell approximately where a battery's at under various conditions, the more I know the battery. And this is actually more output, considerably more than what it was draining. And so if we, like, this is the basic level. When we start doing those other processes, then that battery will not discharge. You know, once you get it just right, like it actually can be too much, like I said, and charge up. We don't want it to charge, we want it to just maintain, because that can be a problem. Like when this charges up, and I've done this sometimes, and it's very dangerous to the circuits. When this charges up fully, and there's nothing left to charge, then it goes, like on the basic level without doing any other stuff, then this battery starts charging. But that becomes, like, once they're both, like I had once 16 volts on these smaller batteries with a bigger system, on both sides 16 volts, and so I could only do that for a very short time before the whole circuit would blow out. And remember this, just because the MOSFET or the transistors are more likely to have damage, the MOSFET, when it has damage, usually it's catastrophic, but sometimes too, even MOSFET, like a transistor, can have damage where it functions but doesn't give you, like, it causes a problem with the charging of a battery. So you have to do a pure, when you're doing experiments, you got to replace your parts. You can't, like people have told me, oh, I've been doing thousands of experiments with this, you know, one setup without ever changing the semiconductors. And like, well, you're not going to get a pure test then, because you have possibly, you know, it's not a pure test because you don't know what you're. I'm not saying throw away those transistors, but if you're going to do a test that's proper control, we want everything, you know, pure. We don't want any other variables in the mix. So everything has to be identical except one variable to really understand cause and effect relationships. So then what else? I think that covers most things here. Yeah, welcome to phase 2, or 20 years later, the SSG, Simplified Schoolgirl Circuit. This one's a little bit more than simplified. It's got at least one advancement here. It's a multi-strand, of course, too. And we're doing already a bigger battery bank. But this is a generation later. And they deleted it. I think they've effectively destroyed this research, and that I don't think whatever I do will go anywhere, because there is really not much interest anymore in this. But I thought I would do this. I don't really have the time for it, but I thought I would do this because we put so much work. I put countless hours and years into this, and then they just erased it. And then I read through that they said at the time that I was threatening to erase it. And so they did they lied. They said the very opposite of what the truth was. And they had removed me from my own groups, and then said that I was threatening to erase it, as if I would ever have done something like that when I'm the one who put so much effort into it. But, it was a thing, and then, they just insulted everybody by shutting it all down and erasing it all. And we do have a lot of the files, so we will try and post them up on a place, some server somewhere, and then you can go through them. All those old emails, that won't be kind of a membership thing. It'll be just out for everybody to copy and paste. And so this is an open source thing. I haven't hid anything from you. The process is all Tesla stuff, and I'll leave that one element in the book. Well, there's quite a few things in the book that I haven't said here, but there's quite a few stuff that's in the videos that I've been sharing over the years. So I'll just say this too: all money that comes into Renaissance Charge doesn't really go to me. It goes to my workers, and so everything that I charge is not really for profit. I'm not making any profit off of this with my pricing that I'm doing it. So I'd ask that people respect that, and that in various ways, like not copy my videos, but direct people to my videos, and also I encourage people to be helpers, to move things forward. There was a lot of team effort in the past, and there's still some right now, but very minimal. So if you give any donations, it will go towards this, making these things happen. We do have a Patreon on the website there, on the YouTube channel. So thank you for watching, and I hope that this can be used by you in some way beneficially, and that you can contribute and help others. Thank you.